page 120 here. And we're going to start talking about graphs of proportional relationships and what those look like. Okay, so first we have Tanya, who exercised for 30 minutes. She noted the calories burned at 3 times during her workout. How can Tanya use this information to find how many calories she burned after 15 minutes of exercise? So we can see she has 10 minutes of work time and she burned 95 calories. So we would plot that as a point, right? 10, 95. And then we have 20 minutes. She burned 190 calories. So we're going to plot a point at 20, 190. And then we have 285 calories at 30 minutes. Now some of you are going to be like, Miss Hus, why can't we just divide that in half? We could, but we're going to do this with an equation, okay? Again, just so that way we can see how that works in case it's not as easy as just dividing by 2. Okay, so we have our graph here. And again, we can draw a line here because we know at 0 minutes, she obviously burned 0 calories, okay? This graph is a straight line. It goes to the point 0, 0, right? And it's some sort of diagonal. It's not a perfectly horizontal or perfectly vertical line. Those are 3 key things to tell if it's a proportional graph or not, okay? And this is a direct proportion. Okay, so we're going to use the graph to find the constant of proportionality. And what they do here is they look at the points that we have. Okay, so we had our point 1095 and 20, 190. So the change, the x change here between 10 and 20 is plus 10, right? We had to add 10 to get there. And then the change between 95 and 190 is a 95-degree change upwards. Okay. So again, our constant proportionality is the y over the x. Well, the y change here is 95 over the x change here, which is 10. 95 divided by 10 is 9.5. So we know that our equation is y equals 9.5 times x. Okay? And we don't have to put the x in parentheses. Now I want to know how many calories did she burn at 15 minutes. So I would have y equals 9.5 times 15, and 9.5 times 15 would be 142.5. Okay, so that is how we would get that answer. And I believe if we divide that by, if we had divided the 285 by 2, we would have gotten 142.5 as well. So again, use your reasonable skills, right? If it's something quick and easy like that, by all means, just divide by 2, right? The issue is if it wasn't an easy divide by 2, right? We might have something where it's, they wanted to know what 23 minutes was, right? That's not an easy divide by 2 in this case, okay? So make sure you do know how to set up that equation. All right, let's try it for ourselves. So we have each 1/4 cup serving of cereal has 3 grams of protein. How can you use the graph at the right to determine whether the quantities are proportional and find how many grams of protein are in 1 cup of cereal? Okay, so we know every 4th cup has 3 grams of protein. So I know at 1/4 cup, I'm going to have 3 grams of protein. If I add another 4th cup, which is 1/2, I would have 6. And if I add another 4th cup, that would be 9, which now all these things are already coming off my graph. And obviously if I have 0 cups of cereal, that's going to be 0 grams of protein. Okay, so again, I know this is a proportional graph because it starts at 0, 0. Okay, it's a straight line and it's a diagonal line. It's not a perfectly vertical like this line, right? Or horizontal like that line. Okay, so it has to be some sort of diagonal for it to be a proportional graph. Start at 0, 0 and be straight. Okay, so now what I can do is I can write an equation of this line. Okay, now what I could just keep doing is I know 3/4 is 9. Well, if I add another 3, right, that would be 12, right? So even though this is off the graph, I know 1 cup is 12 grams, okay? So I could write my equation, y equals 12x, okay? And if I wasn't 100% sure, what I could do is I could say, well, my change between these points from here to here, that change here is 1/4, from here to here is 3. If I do 3, the change in y, over the change in x, I'd have to do my copy dot flip-flop, which would be 3 times 4 over 1, which is in fact 12. So I could find my constant of proportionality either of those ways. But if you can get to 1 on the x-axis, that saves you a lot of time. Okay? So for 1 cup of cereal, we would get 12 grams of protein. Okay? All right, how can you find the constant of proportionality from the coordinates of 1 point on the graph? Well, if I was only given this 1 point, okay, I know the graph has to start at 0, 0. So again, I would have had a change of 1/4 and a change of 3. Okay, so if you only have 1 point on the graph, that's fine. You just look at your change from 0, 0. Okay. Moving on to page 121 here. Okay. So the graph shows a proportional relationship between the distance and amount of time Mr. Brown drives. Again, we can see this is proportional because it's starting at 0, 0. We have a straight line and it's a diagonal line. Okay. What does each of these points represent in the situation? So 0, 0, that means he drove for a time 0, and obviously he didn't go anywhere if he didn't drive, right? 155 means in 1 hour, he drives 55 miles an hour. 275, that means he drove 55 miles in 1 hour, yes. And then 275 would mean he drives 275 miles in 5 hours, okay? Now the constant of proportionality, remember, it means one thing. What is that one thing worth? So in 1 hour, we drove 55 miles, right? That is the constant of proportionality. Again, we could also look here. The change in the x is 1, and then the change in the y here is 55. 55 divided by 1 is 55. So the constant of proportionality is 55 here, okay? So again, our equation would be y equals 55x, okay? So if we look at the try it, we're going to look at the same graph here. So suppose the graph of Mr. Brown's road trip is extended, okay? So they're going to draw the line, keep going here. Find the ordered pair with a x coordinate of 7, okay? So we know that x is 7. What does this point represent? So if the graph is extended, it will pass through the point 7, comma what? Well, all I have to do here is do y equals 55 times 7 because x is 7. And 55 times 7 is 385. Okay? So this means that Mr. Brown will drive 385 miles in 7 hours. Okay. And again, I know this because I'm just reading the x-axis. The x-axis is time. So if x is 7, that means 7 hours. If the y is 320, that means we've driven 320 miles. Okay. In this case, 385 miles. Right? So again, if we're looking at a graph, it's proportional if it starts at 0, 0, or it passes through the origin. That's what the word origin is 0, 0. Okay. And it is a straight line. Okay. But it's not perfectly horizontal or perfectly vertical. Okay, this is not a proportional graph because it does not start at 0, 0. We're missing this point right here, right? Not proportional. Okay, this one starts at 0, 0, but it's not a straight line, right? So that means it is not a direct proportion equation. Okay. So this says draw two graphs that pass through the point 2, 3. One that represents a proportional relationship and one that does not. So I'm going to plot 2, 3 on both of my lines here. So I have 2, 3 going here and 2, 3 going here. Okay, so again, my proportional relationship has to go through the origin. So once I have 2 points, I can draw a nice straight line. But this one, maybe it doesn't start through the origin, right? Or maybe you make a curvy line, okay? All right, I hope this video finds you well. Talk to you later. Bye.